What is the biggest thing that you would say from looking at the past to the threats for the future? What would be your concerns as a scientist? Obviously, man-made warming
But
is
yeah,
a top priority, I think, on everybody's minds right now, or anybody who's a scientist at least, and hopefully more people
yeah.
out there in the world, politicians, etc. But outside of that, are there other things that are kind of like, oh, you're like, huh, this is interesting. This could be happening in the future based on what we know from the past.
Yeah, like there's always like concern, like asteroids hitting the Earth, or like um, coronal mass ejections from the sun being pointed at Earth and like wiping out our technology. Like there's always concerns like that. I'd probably say global warming is probably the biggest concern, that like earth scientists and environmental scientists are primarily focused at, and that's probably where the majority of our research into the past, its main application is to just basically try to understand the future, and just looking basically into the rock record, because that's the best record we have of what life was like back then at any time you're interested in, and actually studying what's the you know what happened back then and what are the implications. Another thing that's actually cool, just sorry to go back to isotopes again, are
Please.
the carbon isotopes. So carbon has a stable isotope that's carbon 12, and then there's that's like the regular version of carbon, we'll call it. And then the actual heavier version that we look at is carbon 13. There's carbon 14 too, but it's radiogenic. But we'll go back to that later. And carbon is basically photosynthesis preferentially takes in carbon 12, leaving carbon 13 into the atmosphere. But what's neat is when you start looking at things like go back to my research during the Cretaceous, plankton would take in carbon 12, they die, they fall down to the bottom of the ocean floor. And if they happen to be, let's say, buried, let's say there was a storm event or anything where they fell and sediment covered them up and there wasn't actually a chance for them to decompose, that carbon 12 that they took into their bodies gets actually locked away in the geological record. And then we can actually start to monitor things like we can create a stable isotope curve, and we can start seeing like, okay, when this isotope spikes here, that means one thing. When this isotope spikes in the opposite direction, it means something else. So we can actually look at these periods of anoxia, like low ox or no oxygen, versus oxia. But what's interesting too is those buried plankton are now our petroleum products. Like fossil fuels came from plankton. So when we burn those, we actually end up getting this very the way you measure isotopes is you put the heavier one on top, so carbon 13 relative to carbon 12. So we'll say carbon 13 depleted, because there's more carbon 12 compared to 13. So it's carbon 13 depleted fossil fuels or carbon being released into the atmosphere. And carbon 14, the radio isotope version of it too, is also useful just because carbon 12 decays after like 5,700 some odd years. So this carbon 12 from those organic matter that we've now releasing as fossil fuels is basically like carbon 12 or carbon 14 depleted, right? That carbon 14 has now completely decayed. So we're actually releasing very carbon 13 depleted or also carbon 14 depleted carbon back into the atmosphere. And we know the volume of Earth's atmosphere and how much CO2 is in. So when you look at the isotopic composition of the atmosphere and you compare it to, let's say, carbon isotopes from, let's say, volcanism, which also releases a lot of CO2, but you can actually look at the isotopic signature of the atmosphere and you can start to compare. And this is one of the ways that we can confirm that, in fact, a lot of the carbon that's in the atmosphere causing global warming is in fact carbon that's released as fossil fuels. Like it has an isotopic signature that matches like what we would expect from the burning of oil.